Hi, this is Tom Loschiavo, Chemistry Education Manager at Pasco Scientific, and I'm here today to talk about how you can do some kinetics experiments with the Pasco spectrometer. So I have the Pasco spectrometer, Bluetooth connected to my computer. I have the spectrometry software open and ready to go, and everything is paired correctly. Today I'm going to do a brief experiment using some crystal violet and some sodium hydroxide. In order to do this, we're going to need to calibrate the spectrometer. So we're going to go to the Analyze Solution page. I'm going to take a blank cuvette of my solvent, in this case water. I'm going to put it in the spectrometer so the clear side of the cuvette is facing the detector and the light. It's going to fit in there snugly so it doesn't wiggle around while you're doing your experiment. I'm going to calibrate a dark reference, which means the light will be turned off in the spectrometer. Calibrate a light reference, where the light will be on, going through the solvent to effectively blank out the solvent. So after it's done calibrating, I'm just going to hit start, make sure it calibrated correctly, and I have a nice flat line at 0 absorbance for my solvent, which is what I want. For my crystal violet, I have a sample of crystal violet in a cuvette. I'm going to put that into the spectrometer. And now I see a nice spectrum. I'm going to auto-scale that. And it's absorbing lots of light in the yellow range of the spectrum, and that's why it appears violet. So to do my time or my kinetics experiments, I'm going to go to the time page, but first I need to pick my analysis wavelength. So I'm going to use my coordinates tool. Coordinates pops up. I'm going to drag it over to the point that I want to use. I'm going to hit check to select that wavelength. I see the line on there, so I know that that wavelength is selected, and it looks like we're around 577 nanometers for this particular analysis. So now I'm going to hit stop, and now I can go to my time page. So the time page is absorbance first time, and it's set right now for a sample rate of 1 hertz, or 1 per second. You can change the sample rate, but that's probably appropriate for what we're going to do. And I'm going to take my sample. I'm actually going to use this sample because there's a little less in it. And I'm going to put in some sodium hydroxide. So I'm going to add about 10 drops of sodium hydroxide. And I'm going to put the cuvette cap on, make sure that's nice and mixed, make sure the cuvette is clean. Put that back in my spectrometer. And I'm going to hit start. So now we see the absorbance in the inset full spectrum. We can see the absorbance changing versus time as the reaction proceeds. So we'll leave this one here unreacted so we can compare at the end of the process. Okay, so we saw the absorbance declining while the reaction was happening. And we also saw the full spectrum, the peak, got lower and lower as the reaction happened. So I'm going to stop the reaction now. Typically, I like the reaction to proceed until the absorbance is at least half of what the starting absorbance was. That way, with your students, you can introduce the idea of half-lives and how long it takes for a half-life to go by. So the nice thing about the software is not only can I look at absorbance versus time, I can also quickly look at the things that are most important for chemistry. So for the reaction orders, I want to look at the natural log of the absorbance and the inverse of the absorbance. More specifically, the concentration. Absorbance and concentration are directly related, and we know that from our Beer's law experiments. So if I cycle through my quick calcs here, I can see the inverse of absorbance and the natural log of absorbance. And what you want to do is you want to find the straightest line, and the slope of that straightest line is the rate constant, or pseudo rate constant in this case. So I'm going to apply a linear fit to my graph. I'm going to hide this inset now, so I can just look at the graph. So there's my graph. with my natural log. Looks very straight. 0.999 is my R value. And just to cycle through the other ones so you can see. The absorbance, which would have been 0 order, is 0.996. Pretty straight. The inverse absorbance, 0.989. But definitely the best fit for a linear fit was the natural log of the absorbance. So now we've done a quick study of the kinetics of crystal violet. We can see that the reaction caused a change in the color of the sample. And we were able to determine the order of the reaction using the software. So, thank you very much. This has been Tom Schiavo. If you have any questions or comments, please reach me at chemistry@pasco.com. Thank you.